previous lecture we discussed about the classification of chopper based on the quadrant of operation of chopper. If a chopper gives first quadrant operation, that both the voltage and current, output voltage and current, average output voltage and currents are positive, that type of chopper is known as class A chopper or type A chopper or first quadrant chopper. If a chopper gives second quadrant operation, that is voltage is positive, current is negative, that type of chopper is known as type B chopper, class B chopper or second quadrant chopper. If a chopper provides first and second quadrant operation, that type of chopper is known as type C chopper or class C chopper. Class C chopper is the combination of class A and class B chopper. Then if a chopper circuit provides first and fourth quadrant operation, that type of chopper is known as class D chopper. In this lecture we will discuss about the four quadrant operation of a chopper. That means a single chopper circuit gives all the four quadrant operation. That chopper is known as class E chopper or type E chopper. This is the power circuit of a class E chopper or a type E chopper. A class E chopper or type E chopper consists of a RLE load, resistive, inductive and DC source load, and 4 semiconductor switches CH1, CH2, CH3 and CH4. And also it consists of 4 diodes D1, D2, D3 and D4. PS is the input DC voltage, and this chopper circuit is known as class E chopper or type E chopper, and it gives all the 4 quadrant of operation. Okay. If you want first quadrant operation, we will operate CH1 switch. That means by controlling pulses to the switch CH1 we can obtain first quadrant operation. If we want second quadrant operation, we will control the switching pulse to switch CH2. We will control the operation of CH2 only. Then we can obtain second quadrant operation. If we control the switching pulse of CH3, we can obtain third quadrant operation. If we control the switching pulse to CH4, we can operate fourth quadrant operation. That is, for obtaining first quadrant operation, CH1 operates. For obtaining second quadrant operation, CH2 operates. For obtaining third quadrant operation, CH3 operates. For obtaining fourth quadrant operation, CH4 operates. CH4 operates means we are turning on and turning off the switch CH4 by controlling the switching pulse to the switch CH4. Okay. First we will discuss about the first quadrant operation. In first quadrant, the output voltage is positive and output current is also positive. And for first quadrant operation, CH1 is operated. That means CH1 is operated. That is, we will turn on CH1 and we will turn off CH1. First, let's assume that CH1 is on. The switch CH1 is on. In order to obtain positive voltage and positive current, we will turn on CH4. Okay, in order to obtain positive voltage and positive current, we will turn on CH4. In order to obtain first quadrant operation, CH1 is operated. First we are assuming that CH1 is on. When CH1 is on, in order to obtain positive voltage and positive current, we have to switch on CH4. Then current flows through CH1 through resistance R, inductance L and EMF E, and through CH4 and back to source. The output voltage is positive and output current is also positive. when CH1 is off. Next, assume that CH1 is in off condition. When CH1 is off, then the positive current will freewheel through the diode D2. And the positive current freewheels through the diode D2 and CH4. Okay, this is the first quadrant operation. In order to obtain first quadrant operation, we are operating the switch CH1. The switch CH1 is in operating condition, means we are giving switching pulse to the switch CH1 only. Then we are assuming that CH1 is in on condition. When CH1 is on condition, in order to obtain positive voltage, we have to turn on CH4. Okay, then current will flow through CH1, through load and CH4 and back to source. Thus we can obtain positive voltage and positive current through the load. Okay, now we will turn off the switch CH1. When CH1 goes to its off condition, then the diode, the polarity across the inductor reverses. The inductor polarity reverses, thus the diode D2 will become in its forward biased condition. Then the CH4 is always in on condition. Then the current freewheels through the switch CH4 and diode D2. Okay, that is the first quadrant operation. Now consider the second quadrant operation. In order to obtain second quadrant operation, we are operating the switch CH2. First, assume that CH2 is in on condition. When CH2 is in on condition, the current flows through CH2. The EMF aids the flow of current, and the current flows through load CH2 and diode T4, and the inductor stores energy when CH2 is in on condition. Now assume that CH2 is in off condition. When CH2 is turned off, the energy stored in the load will fed back to the source. Energy stored in the load fed back to the source. When CH2 is off, the voltage across the load is equal to E plus L into di by dt, which is greater than source voltage. Therefore diode D1 will become its forward biased condition. Then the energy stored in the load will fed back to the source through the diodes D4 and D1. Okay, that is the second quadrant operation. Second quadrant, we are operating the switch CH2. When switch CH2 is in on condition, the back EMF or the DC source E, the load DC source E will aid the flow of current through the load CH2 and T4. When CH2 is in on condition. When CH2 is in off condition, the load voltage is equal to E plus L into di by dt, which is greater than source voltage. Therefore the diode D1 will become in its forward biased condition, and the energy will fed back to the source through the diodes D4 and D1. Now let us consider this third quadrant operation. In order to obtain third quadrant operation, we are operating the switch CA3. First assume that CH3 is in on condition. When CH3 is in on condition, CH3 is in on condition. The current flows through CH3 through the load and through CH2 and back to source. Okay, here we are assuming that our battery load voltage polarity E is in reversed condition. Okay, now when CH3 is in off condition, when CH3 is in off condition, then the energy freewheels through the diode D4 and the switch CH2. Okay, when CH3 is in off condition, thus we can obtain both positive voltage and thus we can obtain both negative voltage and negative current, that is the third quadrant operation. Now consider the fourth quadrant operation. To obtain fourth quadrant operation, we are operating the switch CH4. First assume that CH4 is on. When CH4 is on, the current flows through CH4 and D2 and through the load. Now we are assuming that CH4 is off. When CH4 off, the energy stored in load will fed back to source through the diodes D2 and D3. This is the fourth quadrant operation of a chopper. Fourth quadrant operated chopper is known as type E chopper. Type E chopper. In order to obtain first quadrant operation, we are operating the switch CH1. In order to obtain second quadrant operation, we are controlling the switch CH2. For obtaining third quadrant operation, we are controlling the switch CH3. For obtaining fourth quadrant operation, we are controlling the switch CH4. When switch CH1 operates, CH4 is always on. When CH1 operates, CH4 is always on. When CH3 operates, CH2 is always on. When CH1 operates, CH4 is always on. When CH3 operates, CH2 is always on. That is first and third quadrant operation. For obtaining first and third quadrant operation, two switches are in on condition. For first quadrant, CH1 and CH4 on. For third quadrant, CH3 and CH2 is in on condition. Okay. For obtaining second quadrant operation, CH2 and D4 is in conduction state. And for obtaining fourth quadrant operation, CH4 and D2 is in on condition.